Welcome to the CircuitPython Show. I'm your host, Paul Cutler. This episode, I welcome Michael Czeiszperger. Michael, who described himself in a bio he wrote in 1991 as an engineer who dabbles in writing, musical composition, and computer graphics, skillfully avoiding the mastery of any one field. 35 years later, the list has only grown. Real-time synthesizer prototypes at Yamaha R&D, where he demoed the entire lab's work for Yamaha's president, Solaris audio libraries at Sun Microsystems, and since 1998, his own company, Web Performance Incorporated, building load testing tools used by the US Census, Statistics Canada, and the New York Marathon, most recently shipping agentic AI systems into a 25-year-old enterprise Java platform. Michael just released ScrollKit, which exists because he wanted LED signs showing live theme park wait times, and found that most CircuitPython matrix libraries get you a scrolling hello world and stop. It handles everything after that. Over-the-air updates to boards in the field, fault-tolerant data refresh, transitions and effects, and a built-in web server, all running at once on boards like the Matrix Portal S3, plus a pixel-accurate desktop simulator, so debugging doesn't have to happen on hardware. Michael, welcome to the show.
Hey, how's it going?
How did you first get started with computers and electronics?
If you want to talk about electronics, my dad was a real big believer in the value of hard work in other people. And so he had a buddy who had a TV repair shop and it sent me out to apprentice there like I was 14. And so they put me to work first sweeping floors and then soldering used parts off of old TVs to go in the bins to be used. And so I thought that was the coolest thing. How does it all work? You know, and the other thing I thought was, I do not want to repair TVs. I want to build stereos. That sounds way cooler.
How did you discover CircuitPython?
I discovered CircuitPython because I've been following Adafruit since it started. And so I just think it's a cool company. I like the way they're run. And CircuitPython happened to be a good way to learn how to use their hardware. I've already done C++ programming on ESP32s, and I thought, I know how to do that. But a buddy of mine says, you have to learn Python. And so what a better way to learn Python than to make LED screens light up?
Speaking of LED screens, you recently released ScrollKit for CircuitPython. Tell me about ScrollKit.
I wanted to learn Python, but I also wanted to make a product because I'm kind of like an entrepreneur product engineer. And the product I wanted to make was kind of dumb. And that is a box which would tell me what the wait times were at theme parks because I'm a theme park nut. And as a professional programmer, I sat down and all the different bits and pieces that you needed to put together, I all had to do by hand. It's like, why don't any of these libraries exist? This is I don't mind writing them, but I mean, it should be a few lines of code that somebody else wrote, not me. I mean, all the different pieces. I was looking at page after page of like gobbledygook of trying to get the boards configured. And I thought, somebody else could be saved a lot of time if I just pulled out all the commonalities and made it into a library. And so I happened to be on the API team at Sun Microsystems back in the day for audio. So I had like an eye for, I'm just a real stickler about it should be as simple as possible and extensible so that, I just love looking at a program and it's like line 1, set everything up. Line 2, run the program. It should be logical and easy for even non-programmers to use.
This is version 3. How does it differ from the first 2 versions? What have you learned along the way?
Well, I learned a lot. As you can imagine, version 1.0 actually shipped, and people paid me to ship these boxes out, and it was pretty much crap. I mean, I had tested it at home, but these people would run it on spotty Wi-Fi networks, and it'd be up for 6 months, and they were naive users, and so if the box happened to go blank for 10 seconds because the data feed locked up, they would panic and send an email or unplug the box, and then they'd hose it. I rewrote the thing to version 2, and I thought I was going to fix all those things, and it was more solid then. It was better. It was just completely hand-coded. And then about the same time, AI coding came along, and I thought, I would rather risk learning how to program with AI on this than at work. the first time I said, all right, refactor this into a library, separate it. So I gave it instructions and I let it run overnight, and it came back the next day, and it was literally 20,000 lines of gobbledygook. I mean, it was just horrible. And so it was a long process to figure out, all right, how do I, as a former engineering manager, tell my AI team how to do what I needed to do, which is to create a professional looking library.
So tell me a little bit more about ScrollKit. How does it work?
It's a Python library, but when you make there's a big difference between just running a little demo app on your CircuitPython device and coming out with a product. And so one of the first things that happens is when you give a person a box, it has to connect to the internet. And all of the CircuitPython documentation, it says, first mount your drive and then edit the file with your Wi-Fi password. And no, people are not going to do that have paid for a product. They just aren't going to do that. And so the first thing is there were some regular Python scripts, but I wrote it from scratch that will, when the box comes up, it throws an actual web server up with instructions for the user. So across the device, it scrolls, log into here, and then it allows you to connect your internet. So, it's polish. It's basically product polish. So what happens then? The next thing that happens is, what if the user wants to modify it? You don't want to write an app for that. And then they have to download an app. So then the web server that's running on the box automatically picks up all of your settings that you specified for your app and shows them in a nice GUI so the user can go and change parameters, scroll speed, colors, whatever parameters you want. It automatically throws it up. You just define what your parameters are, and the GUI just takes care of it. Now, if you want to do something complicated, you can write your own GUI too. But the philosophy here is what 99% of people are going to be doing is handled in just the simplest way possible.
Now, when you say box, what hardware have you targeted? I believe it's an S3 matrix portal, and is it Hub 75 displays?
Yeah, that's pretty much the first case. I have a list of other hardware sitting on my desk right now that I'm going to be adding just to add something else. I really like that device, the S3. It is so, it's so easy to put together. It's just a couple of wires. You plug it into a box. The thing runs. There's nothing to solder. It's dead simple for a hobbyist. For me, and I actually went and catted up a really nice enclosure for it too. So the whole thing just mounts. It's got holes in the right place on the side. You just plug in your USB power cable, and it just works.
I've got a project that uses two 64 by 32s together with a nice 3D printed cases. We might have to trade designs at some point here.
Oh yeah, well that's the next step. Once you get one, then you want two, right?
That's right. How do over-the-air updates work?
Over-the-air updates, basically, it looks for a live branch on an GitHub feed. So you can do your development, and then when you're ready for a ship, you can tag it with a release number, push it to the live branch, and then all the boxes have a little button at the bottom on their GUI, and you can say, check for updates. What I typically do is I have a list of people who are using it, and then I just send them an email when there's something with a description and they can upgrade or not.
Sure.
I just remember we haven't talked about graphics.
Right. That was the next question. Perfect timing.
Yeah, we haven't talked about graphics. So one of the first thing that really made me excited about doing this was I don't know if you know the Adafruit demo where they have a sort of like a flocking thing.
I've seen it.
It was in C++. Yeah. All right. So first thing I tried to do is write that in Python. Oh my God, it was just glacial. It was just one thing at a time. And then I looked into it and I realized that some of the graphic calls in CircuitPython are really fast because they're in C and some aren't. So what I actually did was wrote a program that went through and timed each of the graphics calls and made a table. Oh, all right, which ones are fast and which ones are slow. So, all right, now I know which ones to avoid. And then I said, well, okay, what higher level constructs do I really want to do to put together animation to make things walk and make things fly? And just came up with a nice, very simple little kit in order to put sprites in there that all use the fast thing. So the first thing I did was try to redo that flocking algorithm, and it worked this time. By using the fast calls, I've sort of timed it so I could create a flock of about 20 separate birds. That seems to be optimal for the S3. Once you get over that, then it slows down.
That's still pretty impressive that you can get 20 of the birds animating at the same time.
On CircuitPython, to me, the thing is like as slow as on that hardware, it's kind of like writing in BASIC for an old Commodore 64.
And I think that's part of the appeal of learning CircuitPython, and it's some of that back to basics feel to it.
Well, I think you get some of the best creativity when you're restricted. If you had a limited compute power, what would the fun of that be?
That's right. It's all about those constraints.
Yeah.
So you mentioned the speed is one of the challenges. Were there any other challenges you had to overcome?
CircuitPython is different because they have a different HTTP stack than regular Python. They have a different graphics stack. And so trying to get everything running at the same time in the box was challenging because the HTTP is synchronous. But in order to get simultaneous scrolling across the screen and the web server running and the data being updated simultaneously, the background would block every time there's HTTP call. And so I put a lot of effort down the drain in trying to make that IO asynchronous, and it just never panned out. So I decided to work around it by putting up a screen that says, I'm updating now, don't unplug. So the end result of that architecture now is that I can have multiple graphics processes running asynchronously. So at the same time as there's a message scrolling across the screen, I can have an animated swarm form the wait time for the ride. It's so cool. It just sort of like call comes in from everywhere and swirls around and then makes the number. And I think when you have a simple little box like that, it's those fun little animations that make it interesting, that change every time.
I agree. You mentioned that you wanted to start the project off by learning a little bit more about how AI might be able to help. I believe you used Claude. How did Claude help you?
Yeah, well, I came back. I left this project sit for a year, and I learned how to use AI in a corporate setting doing production work. And so I brought that skill set. I thought, what would be fun? I want to have little animations for each ride. There's a ride at Magic Kingdom with the Big Thunder Mountain, and there's this goat that's the sort of the mascot, and the goat sort of shakes his head up and down with dynamite in its mouth. I said, I want that, but I want it for every ride. So I thought, let's try the new Fable. The big model right now that came out is Fable. And I thought, I'm going to create a list of every ride that are my favorites, and then put out a text description of the animation that I want, and then I'll just let Fable chew on that overnight. So I came back and some of them were really cool and some of them were blobs. And so when I realized that I can't tell it to make a guitar, I have to describe what a guitar looks like. And so that was a process. It took 3 different revisions. And then every time it would say, I don't want the head to bob up and down. I want it to rotate. So then every time that happened, I would update ScrollKit. So now you can have little bitmaps that rotate. And then I did a walking mechanism. Then I did a bird flies and flaps. And then I did vehicles, so you can have a road and things walking over the road where the road stays the same and then people walk. So basically, I just iteratively went through each of the rides and thought, all right, what would that be cool? Had the AI create that for me, iterated on it, and then moved all the reusable parts of the code over to the library.
Is there the ability for users to fork your repo and actually give prompts to their AI to build animations for the LED matrix themselves?
Yeah, that's the whole point, is that built into this whole thing is an instructions for the AI of your choice of how to use this, where you could go plug in some thing in your head of how you want it to look visually, and it will try to create an animation that does that. So I think that's really fun. You can look at the code yourself, and it's just so cute to see these blocky little things go across the screen.
It might be a great way to introduce someone to CircuitPython too. Put them in front of it and get them interested in giving the prompts, and then over time they might be interested in going under the hood and learning how it actually works.
That's the idea. People can use as little or as much coding themselves as they want. I think the end result would be if somebody says, I want to do asteroid game or something silly, and then they end up having to write code to do that.
So you wrote a simulator that works with Pygame. How does that work?
Yes. As you know, professional programmers, we like debuggers. I love debuggers. There's nothing faster with a bug to go stick in a breakpoint and then look at all your parameters, see all your values. But when it's running on our hardware, I don't know of a debugger that runs on it. Maybe there's one now, but when I started the project, there wasn't a debugger that would tell you what was going on the hardware. And so I was always putting these output statements, and I'm learning a new language. It was so tedious. So I thought, why isn't there a simulator? There's a simulator for everything else. I Googled and I found some very complicated things online, and I couldn't get them to work. I thought, let me just see what Opus is going to do with this. So I spec'd out what a simulator would work. It took me like several days to iterate on it, and unbelievable. You can hold up a box with the hardware right next to the simulator, same speed, everything. So the simulator actually uses those timings I created for each of the calls. So it knows exactly how long it takes on the S3 to execute each of the calls. So it knows how to do the exact same speed and color. It knows bitmaps. It looks exactly like the hardware.
Oh, that's great.
But you can debug it. You can throw it in the debugger and you know what's going on. So to me, that was like really fast.
So you mentioned that you're really into theme parks, and you have another project on GitHub called Theme Park Waits, where you've used an API, I believe, to display all the wait times on these devices. Mm-hmm. Is that what people are using out in the field that are purchasing this from you, that they're also into theme parks and they want to understand what the wait times are out at the different theme parks around the world?
That's exactly it. So the use case here is that people have scheduled a big vacation and it's 6 months out and they want to get their kids excited. So there's a countdown on it. And so it's they can stick that in the kitchen, and every morning the kids can say, all right, here's what's going on at Disney today. Or, look at that cute animation. Isn't that going to be great? Look, we got only 93 more days.
Well, that's great. Build that anticipation up.
Yes. And of course, I just like having it in my office. I think my wife's tired of it by now, but still in my office.
What's next for ScrollKit?
I was just thinking about that. And I was thinking I really want to make the animation more complicated, because right now it can do simple little things, but I thought it would be fun to try to do simple games on it. Like turn it upside down and do Tetris, or asteroids, or a scroller game.
If people want to learn more about ScrollKit or your work, where should they go? Well,
ScrollKit is at scrollkit.dev. And it's got a whole bunch of sample animations. Every single effect you can do has sample, code, and then an animated GIF showing what it should look like. So it's fun to just look at it. My personal work is just czei.org.
Last question I ask each guest. You're starting a new project or prototype. Which board do you reach for?
Which board do I reach for? I have been doing Unix since BSD. And so Raspberry Pis are just like, they're so capable, and you can SH into them. So to me, that's the comfort zone, right? And so trying to use the S3 was me trying to stop using the same board all the time.
Michael, thanks so much for coming on the show.
Hey, thank you. Appreciate it.
Thank you for listening to the CircuitPython Show. For show notes and transcript, visit www.circuitpythonshow.com. Until next time, stay positive.